Hello, ladies and gentlemen. Today we are going to be taking a look at some review of linear topics. So things like slope, how to tell the relationship between a couple lines, and graphing lines. We're just going to be reviewing these Algebra 1 ideas here so that we can apply them in a geometry sense later on. So for this, you might want a calculator, something to write with, obviously, and your notes. Yep, we're going to write them down, okay? There are certain things on here we need to write down, and I'll try to cue you in when those times come. So our learning targets for the day are that we can find slopes of lines, so we can review how to do that. We are also going to use our slope then to determine if lines are parallel or perpendicular. That's sort of the geometry idea being brought back in. And that we can continue to graph a linear equation when necessary. So the first thing we need to be able to write in our notes, guys, is this idea of slope. So slope is really the steepness or the incline of a line or a road or whatever it might be. We see this often applied, like I say up here, in a road sort of setting. You know the hills in Bismarck that are fun to go sledding down because of the steepness of their slope. That idea, that slope idea, is really important to us in math, in all aspects of math. So in Algebra 1, you talked about slope as being the rise over the run. And this was especially useful when we were graphing things. So when we were graphing, we like to use that slope as rise over run, or when we were looking at a graph, we like to use that slope as rise over run. When we didn't have a graph, maybe we had 2 points, then we would use the slope formula. So this one has x1s and y1s and x2s again. That idea here is that we're trying to find the rise over the run. We're trying to find the change in the y values over the change in the x values, okay? Most of the time, these slopes are going to work out to be fraction values, not always integers like just positive and negative whole numbers here, okay? So we need to be careful that we're allowing ourselves to get that fraction for that slope and understand what that means. And then we're also going to be using today y equals mx plus b, which is the slope-intercept form of a line, where m stands for that slope. So finding that slope in a linear equation means we know where to look in the y equals mx plus b form. So, let's add that onto your notes. So let's go ahead and take a look at this one. You don't need to write this one in your notes, but I would like you to watch here as we find the slope of this line. Now you have options. We said slope was rise over run. You could do the slope formula. You could write the equation of this line and use that to see the slope. But the best way to do it when you have a graph is simply to count rise over run. And to do this, you would want to select a couple nice points on your line. And by nice, I mean ones that you can easily write the coordinates for. Like this first dot down here is 1, 1. This one is 4, 3. You don't want to choose any that are like 2, 1.5 maybe. Okay, you want to make sure that you find those ones that are easy to write the coordinates for. And then we're going to go ahead and think of slope as rise over run. That means you start on the leftmost point and you count. I went up how many? I went up 2 spaces and over 3 spaces. So I went up 2, my rise was 2, over 3. The slope then is 2/3. So this line has a slope of 2/3. We like this as a fraction, okay, as 2/3. You wouldn't want to write this as the decimal equivalency because then you'd end up rounding, and if we were going to compare to other lines, we would have an inaccurate measurement there. So leave that as a fraction. And that's how we would use that rise over run idea. Many times, however, you used other formulas when necessary. So let's think about slope facts. In that example, the positive slope was that positive 2/3 that we found. So it's positive slope if it rises to the right. So if the line is climbing. It's negative slope if it falls to the right. So a few little sketches you might draw in here to help make sense of those words. Positive if it's rising like this. Negative slope if it's falling, like that one. You're going to expect a negative slope value. You get a slope of 0, then that means it's a horizontal line. So the picture will look like this when you look at that graph. If you are calculating your slope using a slope formula or you're counting rise over run, and for some reason you get a 0 in the denominator, that means that the run was 0, this is what's called an undefined slope. And it's a vertical line. It's not tilted at all, okay? It's vertical up and down. It's kind of like the cliff idea. If we were thinking about this as a mountain, it's not really a mountain, it's a cliff. Whereas a slope of 0 is a horizontal slope. It's kind of a boring slope to ski down. It's not so exciting because it doesn't have a slope at all. So these are the four things that can happen when you have slopes. So let's take a look at a couple special types of slopes in terms of our geometry relationship. So don't write this part in your notes yet. That little red box down there, that's the part, that fact that you're going to write into the notes with the rest of your slope facts, okay? We're going to find the slope of each line and we're going to determine which lines are parallel. You may remember this from algebra, but if I look at these lines, it looks like they're all kind of slanted the same way. But there are only two of these three that are in fact parallel to each other. And we'll find out which two they are if we look at their slopes. So I have two nice points on line A here, and if I were to count the slopes from the leftmost dot to the right, I would say I'm going down 1 over 1, 2, 3, 4. So this one has a slope of down 1 over 4, negative 1/4. If I do the next line, line B, I go down 1 over 1, 2, 3, negative 1/3 is his slope. And if I do line C, I go down 1 over 3. So this one has a slope of negative 1/3. Now, which two lines would in fact truly be parallel? Well, in order to be parallel, that means they can't ever cross each other. And it looks like because B and C are slanted the same amount, that's what slope really is, that those two lines are never going to touch. Whereas A has a different sort of slope to it, that means eventually up here, these two lines would touch each other way out there in space if we were to extend them on and on forever. So the fact that you learned in algebra was that parallel lines have the exact same slope. So parallel lines have equal slopes. So we have to make sure that when we think lines might be parallel, we check their slope just to be certain. So please write that fact into your notes in your list of slope facts, if you will. And then we're going to take a look at perpendicular lines because that is another one that happens quite often in geometry. So if I take a look at these two lines, I have line 1 is at 2, 6 and 6, 3 if I were to plot those points. And I have line 2 is at 1, 3 and at 4, 7. There we go. And if I were to plot those points, guys, I'd be looking to try to decide if they are perpendicular or not. Well, if I look at some graph, it might look like they're perpendicular, but how am I certain? You're only certain by using those slope formulas and looking at that relationship. Okay, so let's take a peek. The slope formula is y2 minus y1 over x2 minus x1. And if we label these points x and y, and x and y, just watch now and then we'll write that fact in the box here in a minute. And if we remember that this is from the second point, first point, y from the second point would be 3, minus y from the first point would be 6. X from the second point is 6, minus x from the first point is 2. And if I reduce these or figure out what these values are, I get negative 3 over 4. So this one has a slope of negative 3/4. Now if I do line 2 the same way, x, y, first point, second point, y from the second point is 7, minus y from the first point is 3, x from the second point is 4, minus x from the first point is 1, I get 4/3. What do you notice about that relationship between those two slopes? Well, notice that one's positive and one's negative, so they're opposite signed. Okay, that's what makes one slope up and slope down in order to cross to make that intersection happen. But in order to make the 90 degrees happen, not just any old intersection, perpendicular means it crosses to make 90 degrees. So we have to be certain we get a right angle by the fact that we're talking about positive and negative and also reciprocals. So perpendicular lines, if you remember that fact, have slopes that are opposite reciprocals of each other. Opposite meaning one's positive and one's negative, and then reciprocal, okay, opposite reciprocal meaning they're flipped over, numerator, denominator switch places. So whenever we want to decide if lines are parallel, perpendicular, or neither, this is an example I need you to get in your notes, we would be looking at their slopes to make that determination. Because even if you graph, you're still needing to be certain and showing and proving that they are in fact parallel, perpendicular, or neither. And you do that by doing that slope formula. So let's take a look at line 1 and line 2 in this example, and we're going to decide what relationship they have. So in line 1, I have 2 points, and I'll number them the same as we would here in any other sort of distance formula, midpoint, slope setup. And then I'm going to go ahead and use the slope formula. Slope formula says take y from the second point minus y from the first point, x from the second point minus x from the first point. Careful on that one. Yes, we are minus 3. And if I calculate those values here, minus and minus becomes positive. I get negative 1/2 for that slope. You always want to make sure that you simplify your answer. Now if I do the second line, x or y from the second point is negative 7 minus y from the first point, 1. X from the second point, 2, minus x from the first point, 6. So if I now calculate these values, I have negative 8 divided by negative 4, which is positive 2. And if slope is a fraction, we would write this as 2 over 1. Now look at those two slopes. Hopefully you can see the relationship. We have an opposite and reciprocal relationship happening here, so we would say that these two lines are perpendicular. Now perpendicular is a lot to write here every time, so there is a symbol for perpendicular. Perpendicular lines, you make that notation with an upside down T like this. That is the symbol for perpendicular. Whereas parallel lines are a really skinny 11. So if you need to say that they're parallel, that would be what we would say. Perpendicular would be that upside down T. So in our example here, we're talking about perpendicular lines. Okay, and the last example we need to make sure that you have in your notes, we said we were going to review graphing a line. So let's take a little peek at what you remember about graphing. So in order to graph a line, you want to, the easy way or the fast way is to use y equals mx plus b slope-intercept form. But in order to do that, the y has to be by itself. So we'd have to subtract the 2x here, and you'd get 3y equals negative 2x plus 12. And then when we divide by 3 to get the y alone, remember that's our goal, we have negative 2/3 x, and 12 divided by 3 is 4. So when the y is alone, we can see the m and the b. And remember now the m is the slope. So that's how we move the slope on the graph. That's how we move the lines rise over run. And the 4 is the b, the beginning, the y-intercept. So the very first thing that we plot on the graph, sketch yourself a little mini graph there. You don't have to draw all the grid lines, but maybe number your axes a little bit. We would put our first dot at 4, and then we would go down to over 3 for my slope of the line. And I'm showing my little squiggly marks there only to show you how I've counted down 2 and over 3. But then you would sketch a line through those points. Okay, the equation of this line was y equals negative 2/3 x plus 4. And we have that x-intercept where it needs to be, and we graphed it using that slope. So the big idea with graphing a line is making sure that you can pick out those key things and get that y alone. Okay, so that's our basic review of lines. I want to thank you for taking good notes today.